Hello everyone, I am ARYA S, second year MSc Microbiology student in Central University of Tamil Nadu. So now we are going to discuss on topic effluent treatment process, trickling filter and activated sludge process. Effluent treatment process. Effluent treatment process is also referred to as wastewater treatment. This effluent treatment process is, before going to that, we have to know what is effluent. Effluent is nothing but it is a liquid or sewage waste that is discharged into the water body or land, which will typically contain various pollutants, including chemicals, nutrients, and pathogens, and they are coming from mainly industrial and agricultural runoff. And this term ETP or effluent treatment process encompasses this is that all the methods and steps that is involved in the treating water to remove contaminants that is present in the water before it is released into the environment. And this wastewater contaminants include suspended solids, biodegradable organics, for example, BOD, pathogenic bacteria, and nutrients such as nitrogen and phosphorus. So the discharge of this untreated water can cause several undesirable conditions such as oxygen depletion and the odor production in water body, and it can cause negative effect on human health. Then sludge and scum accumulation. Scum is nothing but it is a layer of dirt. When excessive nutrient is available in the water body, then it will lead to eutrophication. That is the aging of lake. It is a condition when water body is over-enriched with nutrients such as nitrogen and phosphorus, then it will favor the growth of algae and some planktons and other similar plants. So BOD and COD are two important critical parameter in wastewater since they measure the amount of organic matter that is present in the water, which impact the efficiency of wastewater treatment and also the health of the environment. BOD is biochemical oxygen demand, that is the amount of dissolved oxygen used by microbes for their metabolizing organic matter that is present in the water. So oxygen content of fresh water is limited to a maximum of 8 mg per ml. And when BOD is greater, it means the amount of dissolved oxygen which is available for higher animals will be lower. And COD is another parameter, that is chemical oxygen demand, that is the measurement of oxygen required to oxidize soluble organic and inorganic matter that is present in the water. This wastewater treatment includes several steps to remove contaminants that is present in the water. So we can classify these steps into four categories, that is preliminary treatment, which will remove solid large objects that is present in the water by screening, grit removal, oil and grease removal. And the second one is primary treatment, that is mainly to remove solids by sedimentation and sludge handling. And third one is secondary treatment, that will remove organic matter, dissolved organic matter or pollutants that is present in the water by trickling filter, activated sludge, rotating biological contactor, and oxidation cone, etc. And the fourth one is tertiary treatment, that is to remove nutrients that is present in the water. And the methods used are disinfection, chemical treatment, and filtration. So we are going to discuss more on trickling filter and activated sludge, that is comes under the secondary treatment classification. Trickling filter is a type of biological treatment system. Why the name biological treatment system? Because using microorganisms, it helps to remove organic matter, dissolved organic matter and pollutants from the effluent. And so that's why it is also called attached growth system. This is the diagram of trickling filter. And the wastewater is introduced through this feed pipe, and it is distributed through the media by sprinklers or spray nozzles will be there. Through this pipe, this wastewater is sprinkled over the media. This is the media which help to filter the wastewater, and above this media, when water is sprinkled over the media, and above this media, a biological film growth will develop that will be containing of living microorganisms. They will later help for the degradation of organic matter, dissolved organic matter present in the wastewater. This is the collection pipe, and through this outlet, filtered water goes out. As I said, the wastewater is distributed over the media. That media can be composed of crushed stone, slag, rock, or even plastic can be used. Above this media, the wastewater is distributed continuously. And ideal medium should have certain properties such as high specific surface area, thereby they'll allow for more microbial growth and it will enhance the breakdown of organic matter present in the wastewater, and high void space or porosity for good airflow and also water drainage, and it should be lightweight to make installations and maintenance easy, and chemical resistance such as it should resist corrosions. Durability, the media should withstand the environmental conditions, and low cost. These are all the properties they should have. Let's see the working of trickling. Actually, over the media said this wastewater is trickles down, distributed over the media. That media is actually cross comb like structure. This cross comb like structure or cross flow that will enable more biological model of treatment to be accomplished within small space and increase the surface area. Through the rotary arms and spray nozzles, with the help of these two arms or these two pipes, water is distributed evenly. As the water trickles down through the media, they will form a slimy growth on the trickle filter media that is called biofilm or sugar film. This biological purification is mainly doing by aerobic bacteria, and the biofilm that is formed is aerobic only up to the depth of 0.1 to 0.2 millimeter, and the remaining portion is completely anaerobic, and the organic matter is degraded by aerobic microorganisms on the outer portion of biofilm. By consuming organic matter, they will reduce the BOD level in the water. Additionally, as treated water passes through the media, they will help to filter out the solids that is present in the water. As the process going on, the biological slime growth, they will grow thicker and thicker. So the microorganisms that is near to the media, they will lose their ability to attach on the surface due to increase in the thickness of the slime. They will fall off the dripping filter media, and due to the anaerobic condition, they will die later and exit the bottom of the filter as a solid called humus or secondary sludge. So the phenomenon of losing the slime layer is called sloughing, and the liquid washes the slime off, then the media and slime of the media, and a new slime layer will start to grow again. The sloughed off film and the treated water are collected by an under drainage which allows the circulation of air through the filter, and the collection of liquid is passed to a settling tank that is used for solid liquid separation. Some of the water that is recycled back to the filter to maintain moist condition. Let's see the advantages and disadvantages of trickling filter. Advantages, the construction require only less land area and small quantities of filter media for their installation. And effluent obtained from the trickling filter is nitrified and stabilized. And the working of trickling filter require only simple and does not require any skilled supervision. And they are flexible in operation. They are self-cleaning. And coming to the disadvantages, the main thing is primary cost, and construction cost is very high. These filters cannot treat raw sewage, and primary sedimentation is very important before doing this process. And operation troubles like fly nuisance and odor nuisance may prevail. Activated sludge process is widely used wastewater treatment process, which comes under the secondary treatment classification, and it is a multi-chamber reaction unit that make use of mainly aerobic microorganisms to degrade wastewater and help to produce high efficient, high quality effluent. And so to maintain aerobic condition, a continuous and constant well-timed oxygen supply is required. Oxygen is released through the diffusers. Diffusers that you can see in the right side of picture. These are all the diffusers. Like this, diffusers will supply oxygen that is very fine particles of air, and on we can use another way, that is mechanical aeration process. In this process, sewage droplet they will fly due to high turbulence. Sewage droplets or they'll disperse or fly in air, and they'll come in contact with the atmospheric oxygen. Thereby the aerobic bacteria, they'll get oxygen for decomposition. During aeration, the suspended and the colloidal matter, including microbes, they'll form aggregates that is called flocules, and then the sewage is allowed to settle down in the secondary sedimentation tank. As I said, during aeration and mixing, the bacteria, they will form small cluster or flows where when the aeration stops, the mixture is transferred to the secondary clarifier where the flows are allowed to settle down and the effluent moves for further treatment or discharge. The sludge is then recycled back to the aeration tank where the process is repeated again. This is the diagram of activated sludge process. In primary treatment, it will only help to remove the solid substance that is present in the wastewater, and it is also a gravity-based treatment. And the remaining contaminants, such as dissolved organic matter, that are not able to settle down with the help of gravity. So they will move forward for secondary treatment, that is activated sludge process. This process starts with the introduction of wastewater to the aeration tank, where it is mixed with the air or oxygen that is needed for aerobic bacteria for breakdown of organic matter. And activated sludge is a mixture of microorganisms that have been cultivated in the previous treatment cycle, and along with that, air is also supplied. Then, as microbes consume organic pollutants, they will multiply and they will form a floc. And then it is transferred to the secondary clarifier, where here the activated sludge or flocs, they will settle into the bottom, and the treated water is separated. Effluent move forward for further treatment, and the activated sludge, they will recycle back to the aeration basin to make the process very efficient. Sometimes when the aeration is stopped, the sludge float instead of they settling out in the settling tank. That phenomenon is called bulking. The reason for bulking is growth of filamentous microorganisms, for example, sheathed bacteria, that is Sphaerotilus natans. Coming to the advantages, this activated sludge process, they can adapt minor pH, organic and temperature changes, and small area is required for construction, and degree of nitrogen removal is controllable. Minor odor problems and disadvantages are they'll have high operation cost, and for operation skilled staffs are required. Electricity cost is also high, and they're sensitive to shock loads and require continuous air supply. These are all my references. Thank you all. Thank you, Kavya ma'am.